This is a video on solving equations. In this video, we're going to be looking at questions where you have to expand brackets as your first step. In each of these examples, we'll be solving to find out the value of the variable. Here's our first example. In all of the examples in this video, it'll be a good idea to have a look at the question, pause, try and do it yourself, and then play and see if you're correct. If you get stuck, just play a little bit until you give yourself enough of a nudge to continue. Okay, so solving this equation. Like I said, there's brackets in these questions. The first job that we're going to have is to expand the brackets. Remember that whatever is directly in front of the bracket is multiplying into the bracket. In this case, we have 3 in front of the bracket, and it's multiplying by each of the terms inside. So I'll multiply 3 by x to get 3x, and 3 by plus 2 to get plus 6. Nothing's really happening on the right-hand side of the equation, so the 15 can just stay there and wait for a second. So now I have an equation where the brackets have been removed, and I want to just go ahead and solve for x. So, like before, this will just mean I need to first of all get like terms on each side of the equation. So I'll get my x terms on the left-hand side and my constants on the right-hand side. In this case, the only x term that I have is 3x, so I'll keep that on the left. And clearly the plus 6 and the 15 are constants, so they'll go to the right-hand side. Now the 15 is already there, so he doesn't need to really change it all or do anything much for the moment. But the plus 6 is going to move across. Now, if it's a plus 6 on the left-hand side of the equation, if it's adding on the left-hand side, when it comes across, it must do the opposite of adding. So it must subtract. And now I can simplify my right-hand side. 15 minus 6 is 9. Now I need to get the x by itself. So I'm going to bring the 3 across. And of course, this 3 is multiplying here, so when it goes across, it'll do the opposite of multiply, which is divide. And then I can simply evaluate 9 over 3, which is 3. So that's my solution. Like in previous videos, I'm able to verify my solution to be doubly sure that it's correct. To do this, I can substitute it in for x in the equation. You'll notice that when I substituted in the 3 for the x that we had in the original equation up here at the top, I put it in its own bracket. If I type in the left-hand side of this equation into my calculator, I get 15. And 15 equals 15. This is a true statement, so I know that I'm right. Here's my second example. 4 bracket 2x minus 1 equals 12. Again, pause the video here, try this yourself, and then check and see if you're correct at the end. Okay, so the 4 in front of the bracket means that 4 is multiplying into the bracket. So it must multiply by each term in the bracket. So 4 by 2x is going to give me 8x, and 4 times minus 1 is going to give me minus 4. And I still have that equals 12 on the end. Now I'll get the like terms on either side, so the x terms on the left of the equals and the constants on the right-hand side of the equal sign. The 8x is already on the left, so no change there. The 12 is already on the right, so it's just that minus 4 that needs to move across. And of course, when that minus 4 moves across, it's going to be plus 4. It's going from subtracting to adding. And then I can simplify, which gives me 8x equals 16. And then I can just simply bring the 8 across, because it's multiplying here, and divide on the right-hand side. Think for a second, what do I call a number like this in front of a letter? 8 is a coefficient. It's the coefficient of x. What do I call a letter like this that I see in an algebra equation or expression? The x, the unknown, is the variable. And I've mentioned it previously in this video, but what do I call a number like this that has no variable attached? This is a coefficient. Oh, it's not. Sorry, it's a constant. My mistake. Okay, right. So I want to get the x by itself. The 8 is multiplying. It'll come across and divide. So it's 16 over 8, and I divide to get x equals 2. Again, if I want to be 100% certain that I'm correct, I can verify this by substituting it back into the first line. Again, notice that I give the 2 that I'm putting in for the x its own set of brackets. I can type in the left-hand side of that equation, and I'll get 12 on both sides. 12 is definitely equal to 12. So that's correct, which means that my solution for x is correct. So here's example 3. So again, you can see that I've got an equation. I want to solve for x. And in this case, you can see that my brackets are on the right-hand side of the equation. So they're the first thing that I'll deal with. Now, just to point out that there are no brackets on the left-hand side, so I'm just going to leave the left-hand side of the equation exactly as it is for the moment. And my work only starts when I get to the right-hand side of the equation to begin with. So the 4 outside the bracket will have to multiply by both terms in the bracket. So 4 by 2x will give 8x. And then 4 by plus 6 is going to give me plus 24. Okay, so again, separating out the like terms, x is to the left, constants to the right. 10x is already on the left-hand side, so it can just stay put. This 8x is going to move across. Now just notice that while there was no sign written in front of the 8x, it's a plus 8x. So when it comes across to the left-hand side, it's going to become a minus 8x. On the right-hand side, the 24 is already there. I can write it as 24, or I can write it as plus 24. And then the plus 2 from the left-hand side is going to have to come over, and that's going to change into a minus 2. And now a little bit of simplifying is in order. So I've got 10x minus 8x. That's going to give me 2x. And on the right-hand side, 24 minus 2 will give me 22. Okay, so now I'll get the x by itself. So 2 is the coefficient, it's multiplying by the x. So it's going to come across, and instead of multiplying, it's going to divide on the right-hand side. And so my solution is x equals 11. Again, it's possible to use substitution to verify my solution. In this case, there's quite a bit going on both the left and the right-hand sides of the equation. So I would need to type in the left-hand side of the equation into the calculator first of all, or do it in your head if you like. 10 times 11 is 110, plus 2 is 112. And you can also type in the right-hand side of the equation into the calculator. So 2 by 11 is 22, plus 6 is 28, times 4 is 112. We get the same solution on both sides. So x equals 11 is definitely the right solution. Here's example 4. Just for a bit of variety, I've used y as my variable this time. In reality, you could have any letter appearing as the variable, so just be aware of that. If you see something besides x, it's not the end of the world, it's still the same approach exactly. Okay, so in this question, I've got a few jobs that I need to do. You'll see on the left-hand side that I've got 4 in front of this bracket, so 4 will multiply by each term in there. I've also got minus 2 in front of this bracket, so minus 2 will multiply by each thing inside in that bracket. And just watch out that it isn't just the 2, the sign in front of it is also important. There's very little happening over here on the right-hand side, so that's just going to stay as is to start off with. Okay, so I'm going to multiply out now. So from the first bracket, 4 by y will give us 4y, and then 4 by plus 2 will give us plus 8, and then minus 2 by y will give us minus 2y, and then just watch out, because minus 2 times minus 1, I have to think about my rules for signs. A minus by a minus gives a what? When I'm multiplying, it gives a positive. So I get plus 2, because the minus by the minus makes the plus, and the 2 by the 1 makes the 2. On the right-hand side, y plus 13 can just stay exactly as is for the minute, until we tidy up a bit more. Okay, so having a look now across my equation, I can see that I've got a jumble of y terms and constants, and I'd like to separate these out. So I'd like to put the y terms on the left of the equation and the constants on the right of the equation. So on the left of the equation, I already have 4y, he's going to stay put. I also, on the left-hand side of the equation, have minus 2y, so he's also staying on this side, so I don't need him to change. And just to point out that when I say on the left-hand side of the equation, I mean that they're both on the left-hand side of the equal sign. Okay, so glancing across my equation, there is another y term that I want to bring across. It's this y term here. Now just bear in mind there's no sign in front of it. It's automatically a plus. And it doesn't appear to have a coefficient, but I could stick in a coefficient if I wanted to. I could think of it as being plus 1y, and it might be a good plan to stick in that coefficient just so that it's clearer on the next line exactly what you're going to get as your result when you do your adding and subtracting of your y terms. So that plus 1y will come across to the left-hand side and be minus 1y. On the right-hand side, that 13 is already there. Again, you can write it as plus 13 if you like, but because it comes first after the equal sign, you don't have to put that plus in. Plus 8 from the left-hand side is going to come across, and now it's going to be a minus 8. Have I left anything out? Yeah, the plus 2 from the left-hand side, when it comes across, it'll also change and become a minus 2. Okay, so now I can begin to simplify and tidy things up a little bit. So having a look on the left-hand side here, first of all, 4y minus 2y minus 1y. Really, you're looking at the coefficients here. 4 minus 2 minus 1. What's that going to give you? Well, 4 minus 2 minus 1 is 1. So that's 1y on the left-hand side. And on the right-hand side, 13 minus 8 minus 2 is going to give you 3. So 1y equals 3. Now you might spot at this stage that since 1y and y are the same thing, you actually have your answer. But if you kind of prefer to stick with the routine that we've been doing so far, you can, if you like, bring the 1 across and divide. So y equals 3 over 1, y equals 3. It's totally fine to take that step. But again, just to point out to you that if you get 1y equals, then you're effectively at your answer anyway. Okay, so like before, if you like, you can verify just to be totally sure that you're correct by substituting in. Of course, make sure that you put a bracket around your value for your variable every time you insert it into the original equation. You can type in the left-hand side of your equation there, and you get a result of 16. And you type in the right-hand side, and you also get 16. So we're definitely correct. Okay, here's our last example, and there's a good bit of expanding needed to start this off. So again, remember that whatever's directly in front of the bracket will multiply by the bracket and take account of the sign. Okay, so first off, 2 by 3x is going to give me 6x, and 2 by minus 1 is going to give me minus 2. Next, I've got minus 4 in front of the second bracket, so minus 4 times 3x will give minus 12x, and minus 4 by plus 2, remember your rules for signs now for multiplication, is going to give me minus 8. On the right hand side, the 2 is going to multiply out and give us 2x plus 6. Okay, now I need to sort everything out and put the like terms together. So the x terms are going to go to the left of the equation and the constants will go to the right. So let's have a look and see what ones are already on the left hand side. So 6x is an x term, so that's going to stay put on the left. Remember, if it's not changing sides on the equal sign, then it doesn't need to change what it's doing. And the minus 12x is also staying on that side of the equation, and it doesn't need to change what it's at either. But the 2x is going to move across, and it is going to have to change. And at the moment it's plus 2x, so when it comes across, it's going to be minus 2x. And now I've got my equal sign. So I'll have a look now and see, well, what's already on the right hand side of that I can keep over there. Well, the plus 6 is already on the right, that's my constant over there, and I want to keep it over there. So I'm going to write that down first, and I can write it as plus 6 or 6. They're both the same thing. And that's because it's coming directly after an equal sign, so I've got the choice to put that plus in or not. And then I'm going to bring my minus 2 across, so it becomes plus 2, and minus 8 is also going to go across and become plus 8. Okay, so now I need to simplify on the left and right hand sides. So let's have a look. I've got 6x minus 12x minus 2x. Remember, it's the coefficients that I'm dealing with here, and I'm adding and subtracting. So 6 take away 12 is minus 6, take away 2 is minus 8. So I've got minus 8x. If this causes you a lot of difficulty, don't forget, you can use your calculator, you can type in the coefficients. So you can type in 6 minus 12 minus 2, it'll spit out the minus 8 for you as an answer, and all you have to do then is stick the variable on the end. On the right hand side, 6 plus 2 plus 8 is going to give me 16. We're nearly there. So we've got one term each side, and now I need to bring the coefficient of the x across and divide. Remember, the coefficient is multiplying where it is next to the x. So it'll come across and divide. So I'm going to have 16 over minus 8, and I can work this out. And again, don't forget the rules for division of signs are the same as the rules for multiplication of signs. So that 16 is a positive, divided by a negative. Positive divided by negative is going to give me negative, and my result there is minus 2. So x equals minus 2 is my solution. Again, just like in previous examples, we can verify to make sure that we're correct. And again, notice that wherever I've substituted in that minus 2 into the first line of my equation, I've put a bracket around the minus 2. Okay, and then when I evaluate the left-hand side of that equation, I get 2. And when I evaluate the right-hand side after the equal sign, I also get 2. And that's definitely correct. So I'm right. Just to point out, your solution is this number in the box, the x equals minus 2. This is just a little checking mechanism so that I can be 100% confident that I'm completely correct. With all of these questions, the most important thing is to take your time and show all the lines of your work. Don't try to take shortcuts. Don't try to write it all on one line. Don't try to cut down on how much time it takes. Just do every part of the question nice and clearly to guarantee that you come out with the correct solution at the end.